like introduction of to the PSpice, types of the simulation tools which we are using nowadays widely, then various types of analysis, like and then DC sweep analysis, AC sweep analysis, and AC sweep analysis with the low pass filter. Just I'm giving the example, and then coming to the transient analysis and the parametric sweep analysis, and Monte Carlo and the worst case analysis, and how to add the existing simulation setting, and then coming to the board to plot and for the gain margin and phase margin, and we are designing the any filter circuit like a low pass filter, high pass filter, and the band pass filter, any types of filter. So we'll go with the body plot. Then later for lastly we'll discuss about the multiple plots and the traces, how to add in the simulation tools. So coming to the simulation tools, so so nowadays I am having a multiple simulation tools widely being used in the industries. So in all of them, so most of the industries, most of the companies are using the PSpice. So because PSpice is a product of the Cadence or CAD, so easily available. So like a PSpice, LT Spice, and HS Spice, and many more simulation tool, which all function is happening in the during the simulation, so that we can implement and that we can debug on the software itself. So during the designing, so that without any delay we can proceed with the development phase. So coming to the, so in the PSpice tool, we are having a multiple features like having a libraries inbuilt. So in the earlier we were having a cadence or CAD 17.2 sets, having a basic idea about the passive components and the discrete components. So Ohm's law and Kirchhoff's law, series and parallel network, and the voltage drop and the branch current distribution in the selected network, and voltage divider circuit, and the basic of the time domain and frequency domain related concept for the body plot to check the gain margin and the phase margin. Suppose if or these are the features available in the PSpice tools. So depending upon our requirement, we can simulate our circuit. Suppose if are checking with the DC sweep analysis, then if we are dealing with the DC source, then we'll go with the DC sweep analysis. If we are dealing with the AC source, then we'll proceed with the AC sweep analysis. If the time dependent component or the memory element present in the system like a capacitive network and the inductive network, so it store the energy. So during in the, because the it store the energy for the certain period of time, it charging and discharging will occur. So in that case we'll go with the transient analysis and the Fourier analysis. Then we'll proceed with the bias point analysis to check the DC value, and then we'll proceed with the parametric and the temperature analysis. And in the parametric and the temperature analysis also we can check the one parameter. Suppose just I am giving the example, just I'm discussing with the basic network circuit like a maximum power transfer theorem, just I'm relating the parametrics with that. So in that, so we will having a source and we will having a load. So need to check when the maximum power can be transferred. It can be transferred only when the source resistance is equal to the load resistance. In that case, we can transfer the maximum power. So that theorem can be implemented in this parameter, because one parameter is dependent upon the another parameter also. So this, and in the Monte Carlo simulation and the worst case analysis, so we can, in the Monte Carlo simulation worst case analysis, simply we can say that we are playing with the tolerance. We can say, suppose each and every registers having a tolerance level from n percentage to n percentage. Just I am giving the example. So suppose just I am talking about the basic capacitor having a 10% tolerance, or the in the capacitor also the 20% tolerance. So we can just implement the circuit with the help of Monte Carlo analysis. We can provide the minimum value of the tolerance and the maximum value of the tolerance, and we can check the what is the effect on the complete entire circuit while designing the circuit and the during the simulation also. So each and everything. So these are the features which the PSpice is providing in the tool. So coming to the library, then the model editing can be done also. Then the graphical result and the data displays also, and the for the so but in the circuit, then make sure create DRC and the netlist again before simulating it. Suppose if you design the circuit and your connection is just like something somewhere open or something else, then your device the circuit will not be run. So in that case, need to create the DRC design rule check, DRC design rule check. So the DRC, once you will run the DRC, then you will get to know the where the error is occurs, and that particular point you need to rectify the design. Once the design is okay, then you again run the DRC. If the DRC is okay, then you can run the simulation. Now how to proceed the start the project. So before starting the project, then we'll go with the file, then new, then project, then enable PSpice simulation, then the create blank project. This is the points that I mentioned here. Coming slide, I will let you know how we'll proceed, how we have to proceed further. Then as the I told you, the from the library we can get the components like a source and the voltage source and the other sources and the passive components and discrete components. We can get the data. We get the components from the library. Then connect with the help of the wire and the ground. Complete the circuit. Then we'll proceed with the depending upon our analysis, AC sweep or DC sweep or the transient analysis, any types of analysis we have to select also. Then about this. So first, so I hope everyone having a OrCAD PSpice to OrCAD software installed. So just I'm not going to discuss about the installation part because the our colleague Prabhakar has already given the session on to select the project. Then you have to mention the project name. Then coming to the project name, yes, create a press series wise whatever project name you have selected, that active profile will be available over here. Then coming this tool is used for the new simulation profile. Suppose you have suppose you have for the so once you design your circuit, so before run the simulation, so you should also run the DRC where need to modify. So from there only you can check the uh, update or any modification if required from the DRC you can get to know. I have designed a basics of the software also we can calculate, but before with the help of DC sweep analysis, what we are doing here is suppose we are using a 20 volt DC supply from this battery, we can say from this source we are using a 20 volt DC. So from if in the DC sweep analysis, what we are doing here is we are sweeping the voltage means suppose means we are doing the means we are sweeping the voltage from 0 voltage to till 20 voltage with the increment of any specific range. Suppose if I want to increment the voltage with the one division, suppose if I want to increment the voltage with the two division, so with the help of the incremented value we can check the each and every movement of scenario, what is the behavior. Suppose on the 2 volt suppose input voltage is 2, at 2 voltage of input, what is the output behavior of the signal. So each and every movement of the time we can check. Well, later you can check memory element which stores the energy for the small period of time, times of the duty cycle. So 3 into 1 by 60 is equal to 50 millisecond for the final time. So for the and the ground. Once the circuit is completed, then we'll proceed with the analysis type. Analysis type, just we can again change the analysis DC sweep to now just I want to check here the time domain analysis. We can check the time domain analysis here. Then again run to time. How many means for the what is the simulation period, and for the much times you want to simulate the circuit. So here I want to simulate for the 100 milliseconds. Means form you can check that. So this is the red signal is just like an input signal, and the green is just like a output, rectified output waveform. So here just we can see that this is the positive half cycle. So during the positive half cycle, it will diode will be in the positive forward bias. In that case, the supply will pass to the output. But during the negative half cycle, diode will be in the reverse bias condition. So in the reverse bias condition, the our device will circuit will not work. So it will pass only the positive half of the input signal. Negative half will be clipped from the output. We have to place the capacitor on the output side. So here in the coming plot window, how to differentiate the how we can plot the different system, different signal on the this output window. So that will also I will discuss also. But coming because in dB point, and on what point we are getting the means we can check the gain margin ultimate means check the gain margin and the phase margin.